At a press conference with the director of the US Office of Management and Budget earlier this month, a journalist raised her hand. What message is President Trump trying to send by cutting funding for climate change research, she asked. The answer?
Regarding the question as to climate change, I think the president was fairly straightforward. We're not spending money on that anymore. We consider that to be a waste of your money.
Most of the world's scientists and other governments don't consider tackling climate change a waste of money. But this week, President Trump signed an executive order rescinding Obama-era rules aimed at curbing global warming. With one of the world's richest countries backing away from its commitments, fragile international agreements to deal with the problem, agreements which were already thought by many to be too little too late, are even less likely to succeed. I'm Ruth Alexander. This is The Inquiry. And we're asking, do we need a plan B for climate change?
Part 1. Plan A.
I particularly remember one visit to the Canadian Arctic, to a place called Iqaluit, and speaking to some of the people there who said to me that the climate was something they were so intimate with. They felt that it was like a friend that they knew well that was suddenly acting strangely.
Our first expert witness is Emily Shuckburgh, a climate scientist with the British Antarctic Survey.
They told me how they would hear robins singing from the roofs of their houses when previously they'd never normally had robins living in that part of the Arctic.
Emily Shuckburgh says that when she hears those personal stories and then looks at the raw data, the picture that emerges is powerful and clear.
We've been putting more and more carbon dioxide into the atmosphere, primarily through the burning of fossil fuels, but also as a result of cutting down forests. Carbon dioxide is what is known as a greenhouse gas, and that means that if you put more of it into the atmosphere, the world warms up. And we've been seeing that. Over the last 150 years, the world's warmed, on average, by about 1 degree centigrade.
In the early 90s, the world woke up to the problem. 197 countries ratified the United Nations Framework Convention on Climate Change, with the aim of preventing dangerous human interference with the climate system. In 2005, the Kyoto Protocol was agreed, setting emission reduction targets. And in 2015, in Paris, an agreement was signed to strengthen the global response to climate change.
We can leave behind on Earth a legacy for our children and our grandchildren, generations to come.
They agreed to keep temperatures well below 2 degrees centigrade and, if possible, to keep them at 1.5 degrees centigrade increase compared to what's called pre-industrial levels.
That plan is focused on reducing emissions. For the world's richest countries, that means
moving away from coal and moving towards a greater amount of renewable energy. And also, in conjunction with that, moving, for example, our transport system to one that's dominated by electric vehicles.
How likely is it we can meet those commitments?
How likely is it that we'll meet the temperature goals?
Your pause says a lot.
It does, doesn't it? If you add together the total pledges that different nations have to date put forward, it's not sufficient to meet those objectives. The current pledges that countries have made are putting us more on a trajectory towards 3 degrees or more.
So despite our efforts to cut carbon emissions, the world is on course to be at least 3 degrees warmer than it was before the Industrial Revolution by the end of this century. That's a whole degree warmer than the target. It doesn't sound like much, but scientists say that would push us much further into the danger zone, increasing the risk of large sea level rises and the collapse of precious ecosystems like coral reefs. We were way off target even before the United States elected a president intent on ripping up his country's carbon emissions commitments, potentially weakening the global political resolve to find a solution to global warming. So is it time to admit we're not going to stop climate change by cutting emissions and consider whether there's something else we could try?
There are also much more exotic technologies envisaged.
Technologies we'll hear about in the next 3 chapters.
I think it's important that Plan B is discussed, that people understand what the options are.
Part 2. Plan B.
Our second expert witness is a German living in the US desert.
It's actually very nice.
But that's not the reason Klaus Lackner moved to Arizona.
My technology is particularly good in a desert environment.
Klaus Lackner is a physicist turned engineer and has spent the past 25 years trying to figure out a way to tackle the amount of carbon dioxide, or CO2, in the air.
It piles up in the atmosphere, and I think there is generally a misconception that if we stop emitting, the problem will go away. If we stop emitting, the problem stays constant. Roughly half of the CO2 will be with us for several hundred years, and to get out of the atmosphere system will literally take many, many millennia.
He says the international agreement to reduce emissions of this greenhouse gas just isn't enough.
If I were to dump my garbage in the street in front of my neighbor's house, I wouldn't be applauded for reducing my garbage by 20% compared to last year.
In 1999, Klaus Lackner was the first person to suggest that instead of finding ways to dump less rubbish into our atmosphere, we should concentrate on finding ways to clean it up instead.
So in the garbage analogy, we are the street sweeper.
Removing carbon dioxide from the air is known as carbon capture, or negative carbon emissions technology, and Klaus Lackner is now the director of the Center for Negative Carbon Emissions at Arizona State University, where he's developing his big invention.
What I came up with you could call a synthetic tree. It probably will not quite look like a tree, but it has in common with a tree the feature of having a leaf, right? It has surface. And it probably looks a little bit more like a bundle of drinking straws where the air blows through.
That's a pretty funny-looking tree, but it would be about the same size as a tree, and it would act a lot like one. The leaves, which are what look like drinking straws, are covered with a special surface that CO2 sticks to. So, you plant your synthetic tree, the wind blows through the straws.
And maybe 30 minutes to an hour, depending on the exact design, these leaves will be loaded with CO2.
I know what you're thinking, though. We could just plant more trees, couldn't we?
Up to a point, yes.
And other scientists have been looking at growing plants which do naturally absorb CO2.
But if you look at the sheer scale you would have to get to, you would need to plant more land than we currently have under agriculture.
Klaus Lackner's synthetic tree also absorbs CO2 much more quickly than a regular tree.
This device would collect 1 ton of CO2 a day. Compared to a tree of that size, it's about 1,000 times faster.
Once the synthetic tree is fully loaded with carbon dioxide, you spray it with water so it releases the CO2 in a highly concentrated form, which can then be stored. So where would you put it?
Right now, the best established technology to put CO2 back out of the way is to inject it deep underground.
He says it can be stored at high pressure as a liquid in spaces cleared by our oil and gas drilling.
I know that the United Kingdom is looking at putting a lot of CO2 into the old gas wells in the North Sea.
How many of these mechanical trees do you calculate we'd need?
You would need 100 million, because then you would operate at the scale the world is currently emitting. Now you can ask, is 100 million units a big number or a small number?
It sounds big. On the other hand,
we build 80 million cars and light trucks every year worldwide.
Rolling out Klaus Lackner's 100 million synthetic trees would be a huge undertaking, but one that could clean our air. But he's been working on this idea for 25 years. If it's such a good one, why hasn't it been adopted yet?
Well, it costs money, right? It's not free to build the first one, to engineer all the bits and pieces. We are talking about $10–20 million.
Although once the prototype had been built and tested, Klaus Lackner reckons each synthetic tree would cost much less to construct, $30,000. And anyway, he says, it should be less a matter of price, more of priorities.
With sewage, we are perfectly willing to pay for it because we as societies understand that the alternative of simply ignoring the problem is far, far more detrimental to us.
With climate change,
we haven't quite gotten to that point.
But even if we do come round to the idea of spending money on synthetic trees, it would take decades to develop the technology into a workable plan and to then clear enough carbon dioxide from the air.
If we develop this technology, we will be late and we will have to deal with some of the damages.
Perhaps then we need to amend our question. Do we need a plan C for climate change? You're listening to The Inquiry with me, Ruth Alexander. All our programmes are available as podcasts, including on the subject of the environment, Can Coral Reefs Survive? And How Did We Save the Ozone Layer?
Part 3. Plan C.
Our third expert witness is Hugh Hunt, a reader of engineering at Cambridge University and an advocate of a taboo idea.
Not many will talk about it. It's the proverbial elephant in the room, in my view.
Well, this is The Inquiry, so let's hear the controversial idea.
Can we reflect sunlight to help cool the planet?
In other words, the planet's getting too warm, let's turn down the heat of the sun a bit.
We could paint the roofs of our houses white. We could scatter the deserts with reflecting metallized particles. We could make clouds whiter. We could put reflecting panels into orbit around the Earth. There are lots of ideas.
Make clouds whiter. It sounds crazy, audacious, but scientists are giving this thought. They're specialists in what's called geoengineering, the science of tinkering with planet Earth's climate that also includes carbon capture, which we heard about in the last chapter. The idea of deliberately interfering with the sun's rays is much more radical, but feasible, Hugh Hunt says. One plan involves filling the atmosphere with particles, much like a volcano does.
When a volcano erupts, you kind of think of all the really messy stuff, the rock and the dust and the ash, but a very tiny ingredient is this sulfur dioxide, which is spewed up high into the atmosphere in a jet that slowly mixes with water vapour in the upper atmosphere and forms tiny droplets of sulfuric acid. And those droplets reflect sunlight really well.
They're basically the perfect size to scatter the sun's rays, reflecting some away from the Earth and back into space. And although I struggle to think of anything hotter than a volcano, scientists have found that, paradoxically, volcanic eruptions do in fact lower the temperature on Earth.
Mount Pinatubo, for instance, in the Philippines in 1991, it put millions of tons of sulfur dioxide high into the stratosphere and caused a global cooling of around 1 degree or so over a period of 6 months to a year.
Scientists have studied this and other volcanic eruptions in great detail and concluded that if we make like a volcano and pump sulfur dioxide into the air ourselves, we could block out some of the sun's heat.
If we want to cool the planet by about 2 degrees, let's say, we need to get 10 million tons of little particles high up into the stratosphere.
So how would we do it?
The easiest way is with aircraft, but you'd need perhaps tens of thousands of aircraft flights per day. One idea that I've been involved with is to have big balloons up at 20 kilometres with a pipe dangling below so you can pump stuff directly into the stratosphere. There's other ideas like having airships or missiles deliver these particles. Every idea sounds more mad and more reckless, but as I say, we've got to keep all options on the table.
If we did pump sulfur dioxide into the air, the effect would be widespread.
In about 2 weeks, anything you put in the stratosphere over England will have made its way all around Northern Europe, all the way around Russia, all the way around America, Canada.
the droplets of sulfuric acid would filter a fraction of the sun's rays shining over that vast area for 6 months, maybe a year. The Earth would be a little cooler, the sky a little less blue. And sulfuric acid, that's what causes acid rain.
I think pretty much everyone worries that sulfuric acid in the stratosphere will have damaging effects on atmospheric chemistry.
Solar radiation management, the specific name for this form of geoengineering, is controversial and untested. But Hugh Hunt says the risks could potentially be controlled. He doesn't think it's the perfect solution to global warming. It wouldn't do anything to solve the problem of the rising level of acidity in our oceans, for example. But it's something that might be worth doing, he says, to keep the global temperature down while we try to reduce our CO2 emissions.
To help us to control, well, what is a pretty deepening crisis ahead of us.
He says climate change is so serious we need to consider all options.
We need a whole alphabet of plans, reducing our energy consumption, finding ways to suck CO2 out of the atmosphere, using solar radiation management to reflect sunlight from the planet. These are all A, B, C, D, E, F and G.
Hugh Hunt thinks the technological challenges of blocking out the sun could be tackled. But when you look at Plan C more closely, you realise that putting it in place would require not only major scientific effort, but major global negotiations, even more complex and sensitive than those involved in reaching the current political settlement on climate change. That's because the stakes would be high.
Part 4. Back to Plan A.
NASA Ames near San Francisco had a conference, the first conference on geoengineering, and I went to it.
Our final expert witness is Alan Roebuck, an American climate scientist and distinguished professor at Rutgers University.
There were all these engineers and physicists talking about how easy and fun it would be to control the temperature of the whole planet.
And yet,
it was in this room that was a little too hot, and people couldn't figure out how to adjust the thermostat and cool the room off, and I thought that was pretty ironic.
The fact they couldn't control the temperature of the room, it didn't fill you with confidence.
No.
Alan Roebuck took his seat and listened to various scientists speaking about the bold idea to turn down the heat of the sun we heard about in the last chapter, and then he took out his notebook.
I started writing down things that I thought maybe this wasn't such a good idea, and I got up to 20 reasons. And I've been thinking about it some more, and I've crossed a couple things off the list, but I've added other things, and now I have 27 reasons.
Let's hear them. Well, not all 27, just the main ones.
How much is it worth to be able to see the Milky Way? How much is it worth to have a blue sky, and how do you evaluate that?
There are questions of aesthetics, and also of winners and losers, because this technology could only be done on a global scale.
If you block out the sun, it cools the land more than the water. And so this land-ocean contrast is what drives the summer monsoon circulation over Asia, over India, over China, and over Africa. So if you cool the land more than the ocean in the summer, that will weaken the monsoon. And a couple billion people depend on that for their livelihood.
There's also a really simple but huge question. I mean, who would control the thermostat?
Exactly. That's one of the items on my list. How could the world agree on how to set the thermostat? As you see, we're having trouble getting a consensus on what to do about emissions of greenhouse gases.
And if negotiations failed, he says, the diplomatic fallout could have dire consequences for the planet.
Let's say you're doing it for a while and you're reducing the warming, and then there's a big drought in India or a big flood in China, and they say, you geoengineers, you're causing this, stop immediately. And so the world loses the political will or the technology to do it, and the particles fall out of the atmosphere in a year or so, and you get this rapid warming as the sun becomes more intense at a rate much faster than you would have gotten with gradual global warming.
It could have devastating effects for ecosystems, he says. And what if this technology could be put to other, murkier uses?
It was about 6 years ago now, a couple guys called me up and said, we're consultants working for the CIA. Can we ask you a question about geoengineering? And I said, yes. And they said, if some other country was trying to control our climate, would we know about it? And I thought for a while, and I said, yes, we probably would, because if a country was flying airplanes up into the stratosphere and creating a thin cloud around the world, we could see that cloud. And they said, okay, thank you, goodbye. And after they hung up, I thought, they're probably asking me another question too. If we want to control somebody else's climate, would they know about it?
So solar radiation management could be a solution for climate change. It could also be a new method of warfare.
Yes.
Hang on. If Alan Roebuck says there are 27 reasons you shouldn't do geoengineering, why does he still research the subject? He says he thinks it's worth all of us knowing more about it.
If somebody asks me, what do I work on? I say geoengineering. And they say, well, what's that? And I say, well, okay, we're going to fly a plane up over your daughter's school and spray sulfuric acid in the air to reflect sunlight, and that's going to reduce global warming. And they say, what? You're thinking of doing something that crazy? Maybe global warming really is a serious problem. Maybe we should focus more on Plan A. Maybe we should really try harder to reduce the emissions so you don't ever have to get to that point.
So Plan B might be successful in solving climate change without ever having to be put into practice.
That's right. If we show that it would be even more dangerous, that would put further pressure on reducing the greenhouse gas emissions.
Do we need a Plan B for climate change? Scientists believe the world is heading towards a climate emergency and that current international plans to cut emissions won't be enough to avoid it. The fact that the new US president thinks tackling climate change is a waste of money doesn't help. So yes, it probably would be a good idea to know what else the world could try if Plan A fails and the planet continues to warm. But the alternatives we've looked at in this programme are complex and risky. We need to know a lot more about their potential consequences. And any last-ditch attempt to re-engineer the Earth's climate would require an international agreement at least as complex and fraught as Plan A, cutting emissions, has been. By seriously considering a radical and potentially dangerous Plan B, perhaps we'll decide to redouble our efforts to make Plan A work instead. But by then, of course, it might be too late. This edition of The Inquiry was presented by me, Ruth Alexander, and produced in London by Kate Lamble. The programme was mixed by Tom Brignall. The editor is Richard Knight. Next week we're asking, why is no one trying to stop the war in Yemen? Brignall. The editor is Richard Knight. Next week we're asking, why is no one trying to stop the war in Yemen?